A warm welcome to all of you who have joined here. On behalf of St. Joseph Institute of Technology and Department of Mathematics, I take immense pleasure in welcoming you to this 3 days online workshop on exposure to data analytics software. Today, we are honored to have Dr. S. Valarmathi to enlighten our knowledge. Dr. S. Valarmathi is working as Research Officer Statistics, the Tamil Nadu Dr. MGR Medical University, Chennai. She received a doctoral degree from Bardiyar University, Coimbatore. Her doctoral research was on survival modeling in competing risk. She is an alumnus of University of Madras and Annamalai University. Her areas of interest include research methodology, biostatistics, and survival modeling. She has more than 15 years of teaching and research experiences. She has published more than 33 research articles in reputed international journals with a good impact factor. She has published 2 books on research methodology and biostatistics. She has undergone several trainings in epidemiology, biostatistics, data analytics, and data management softwares. She received Rashtriya Gaurav Award from India International Friendship Society during the year 2014 and Mother Teresa Gold Medal Award from the Global Economic Progress and Research Association during the year 2013. She is a well-known speaker as she has delivered her lectures in various institutions. Such renowned person is our today's speaker. Her accomplishment is a big list. We are very much delighted to have you here, ma'am. We thank you for acknowledging our invitation. Once again, I extend a cheerful welcome to you all. Your presence makes us very happy. I hand over the session to Dr. S. Valarmathi, ma'am, to elaborate on the topic.
Thank you, Mr. Satish Krishnan. Shall we proceed with our presentation directly? Thank you for the management and the Department of Mathematics for inviting me to give a lecture. Okay, shall we proceed with my presentation?
Yes, ma'am. Yes, ma'am.
Is it visible, Doctor?
No, ma'am. No, ma'am. It is not visible yet.
I think, have you stopped sharing?
I have stopped sharing, ma'am. You have to share it now.
Is my screen is visible?
No, ma'am.
Yes,
Now
ma'am.
it is. Yes, ma'am.
Yes.
Yes. Yeah. Really, it was a different environment to give a lecture for me as from the medical university, but it's very much pleasure to give you the insight of predictive analysis. See, basically, predictive analysis is an area of data mining where you can gather so much of information, and whatever the information needed for predictive, we can extract. Actually, the predictive model or a trend is going to make an insight on behavior patterns of the persons or something which you wanted to progress on seeing the predictivity, what happens in the future with the historical data which we have. With that, we will predict the future events and we will be very cautious how to prevent it or how to progress our business deals or how to proceed in the future. Okay, especially predictive analysis is nothing but it uses the current or the past data and to predict the future. Actually, it uses the current data as well as the past data if needed to predict the future. 1990s, there are few business intelligence that was used. Traditional business intelligence, it's really a descriptive way. Just they have described the analytics, and they have asked like what happened in the past and how many or how often, where it has occurred, like that they were discussing, and where exactly is the problem with the descriptive nature, like describing the whole situation from the history what has happened, and they have taken some actions needed. So it is like a intelligence, our intelligence or IQ, which has reported the descriptive analytics, and with the help of our IQ, we have predicted the data. But in 2000s, slightly it has entered a statistical models where what the models were predicting us, why is this happening, why it is happening. That was the importance of the statistical model to give answer why this is happening. And especially it just go into the forecasting. What if these trends are continued? For example, now the COVID is happening, and if these trends of infection is going to continue, what will happen in future unless we found out a vaccine? This trend can be controlled or not. See, we are still in lockdown because we are not able to bring it into a control of the increasing trend of the infections. So we will find the trend and how we can, whether we need to lock down or we need not to we need not continue to lock down. All these factors we can implement by forecasting the data which we had. This was the thing, and now it's slowly predictive analytics. See, this trend continues. What I can do next? What I can do next for this trend? That is the thing. And finally, I can see what's the best that can happen. That is the decision optimization which we can do with the predictive analysis. So foresight, I need to have, suppose in this 2020, this is going to happen, what I can do in the future years that I can optimize and see or simulate the data and see what happens. That is called as advanced analytics. See, predictive analytics is a broader field wherein we have so many things, like from the customer support call to fraud happens with the credit card, or some energy demand forecasting, like predicting a next day stock, or predicting new clusters, like who are all purchasing. See, suppose more of the persons are buying a red color dress. So if they can analyze and see that more of the persons are very much interested in red color, slowly the manufacturing unit will produce more of red color dress. See, that is the pattern which you are giving more of the, see, Flipkart or Amazon, which you are going to predict a red color dress. So many of people are picking up a red color dress or a particular pattern or some fashion dress, and in the future they will manufacture the same kind of dress or same kind of red color dress. So that is called as text analytics, wherein you are choosing in Amazon or Flipkart or any social network which you are discussing that this particular color or this particular fashion or this particular shop, like that, if you are going to have, then with that help of that, they will be predicting the manufacturing rate. So many information. See, predictive analytics has a larger growth, and wherein engineers, especially engineers, has a major role to play, because they will be thinking in a logical way wherein the other people lack. So logical thinking and quantitative aptitude is more engineer, where they can easily predict the future. Okay, so what are the case types you will be having? Like if it is a category, like what is the likely reason for a customer support call? If I ask for a customer something that my Airtel network is not working, what is the support they are giving? Just a category, whether they are giving or not. Or sometimes it's like a transaction. Suppose I did this transaction, it is whether it is going to be a fraud or it's a normal transaction, that I can use an analytic technique called classification, and I can predict something. And predictive value is nothing but to forecast the stock price, whether I need to inverse the share price or not, like that we could predicting. And this is regression, and this regression is that I am going to talk now, because it is simpler way to explain within this shorter period. And clustering, classification, or association analysis are bigger in terms which you can learn in future. Just this will be an eye opener for all of you to know what it is. Okay, see, for example, there are variables. When I take variables, there are broader categories like categorical variables or continuous variable. Categorical variable, I mean that if you are going to tell yes, no for a question, yes or no, then there are two categories only, either yes or no. For example, gender is a category where we will have only two categories, either male or a female, or a man or a woman. Like that, we will be having a category. But in continuous, see, suppose you are taking a weight 50 and 50.5 all as a meaning in it, then it becomes a continuous. So whenever you wanted to predict a continuous outcome, we will be using the regression technique. Whenever it is a categorical in nature, we will be going for a logistic regression. So other models you can see wherein you can do ample number of predictive analytics, which you can go through. Okay, see, first of all, what you should know whenever you are going to become a predictive analytics or a data analyst, first you should see how the data is. You need to understand the data, whether the relationship exists in the data, and you need to prepare data because see, there will be so many variables we will be collecting while doing the study, or so many variables will come into the picture when they were collecting the data. But whenever I am going to understand the data or I'm going to model the data, I need to narrow down some of the variables which is more relevant, and I need to prepare the data for my analysis, either in a Excel format or in a CSV file or anything you can do, and slowly you can build and evaluate a model if the data is if the data has the relationship between the variables. See, for example, India produces 1.5 million engineers every year. What determines the salary and the jobs of these engineers are offered right after graduation. So after you have finished your UG, how the jobs you will be getting, can we predict the salary from historic data? See, they usually what they will do, they will see the demographics, where you are born, what is your gender, what is your date of birth, how old are you, and they will simply see your high school grades and high school board, and then they will see your marks in the UG and aspiring minds, especially what is your cognitive behavior, personality scores, quantitative. All these things will decide to become employment, to get employment, and they will fix the salary according to that. Mainly, don't worry about your high school grades or high school board grades. It's a prerequisite. But if you are well trained now in data analytics, you will be rocking. If you just pass in your engineering and you are going to take up a career in data analytics, then definitely you will be getting a more salary as compared to others. Okay, so data analytics, you need to prepare an aversion to it, and you need to learn separately, like out of school learning, out of from your engineering. You have to upgrade yourself for the data analytics. There are many persons who are giving training like Data Camp, Coursera, and so many persons are giving training for these courses, data analytics software. So each one of the thing you can learn. So yesterday you have learned Python or R, that plays a major role, and this software which I am going to tell also will have some features for predictive analytics. Okay, how you can understand the data? First, examine the summary characteristics, number of records or features, what is your target variable, what you are interested to predict, and identify the problem, and finally visualize the data with the help of some diagrams like scatter plots. So why data understanding is needed? Because once you understand the data, then only you can prepare yourself to predict something. So for example, you need to find out whether there exists a linear relationship between the predictors and the target variable. And predictors, that just the predictors, that is the what you are going to predict or what you are going to have in as an outcome, whether it is normally distributed and not highlighted, then we can go for the regression tools or predictive analysis. So today I'm going to talk about SPSS software, which is nothing but statistical software packages used for statistical analysis. Especially it is produced by SPSS as separate unit in 1968, and it was called then as statistical package for the social sciences. Later they changed to statistical product and service solution, Now it is known as IBM SPSS, where the students will be using that. Many of the colleges will be using that. But when you enter a IT field or IT company, they will be using a software. The same pattern of the software will be there, and it is named as PASW. PASW is nothing but predictive analytics software. Okay, that is the thing they will be using in that. Well, SPSS is only for is a friendly nature software. Okay, wherein we can use it. So what is the feature of SPSS? Originally developed for the people in social sciences, social science areas. Therefore, no heavy programming background. See, for this you need not know big programs or skilled programs to do SPSS. Designed as a user-friendly and as a pull-down menu. Just you can pull down the menus and you can execute the statistical commands, and you can ability to do data management and manipulations, whatever. And ability to store the analysis programs. You can also see whenever I pull down the menus and do the statistical comments, it automatically saves a program language that is called a syntax in the SPSS. I can do the storing of the analysis, or I can store the programs, that is syntax, through this procedure, and whenever I need it, I can just run the syntax and get the reports done. So file formats, normally it will be as a basic format, like you whenever you save XLS, you will be having XLS or CSV file, data file, like that. Whenever you save the SPSS file, it will be with the extension SAV. Okay, and SPSS syntax file will be having an extension SPS. Okay, .sps, like .xls, .doc, like that. You will be having the basic data file saved in format .sav, and SPSS file you will be saving at .sps. Okay. Why the people are not using SPSS more in nature? Because it's very expensive. At least it's not free. Okay. Whereas your R and Python are a very open source software, but SPSS is not so. Basic package is not tailored for data mining. So there are so much of data now pouring in where we cannot use SPSS, but in the IT environment, the predictive analytics software is under development, and they are bringing it so many things into that. Okay, and it's really a heavy software. People feel in the expensive way or storing the data. It all those reasons make them not to use SPSS in the IT environment. Why use it then? Why I should use? Very rich collection of statistical tests and methods are inbuilt, wherein I can just plug in, pull down menus and just keep the menus here and there, and I can find the analysis. Output are extensive set of matrix and statistically really important factors are included in this model, and really a good support available, and really you need not know the computer science skill for using this data. How the SPSS program flows in is, you will have a data source or a raw data. You will make that data as a SPSS data file and just do the data modification or transformation, like some calculation if you need to do, then you have to do, and finally you can go for a data analysis by pulling down the menus which is already there. And for data modification and transformation, or for data analysis, if you are very much skilled in programming language, you can go for a syntax menu. And getting started, it's simple. Once you have downloaded your SPSS, just double click on the SPSS on desktop or a program which contains SPSS file. Just file open, and you will be getting the menus, and towards various pull down menus will be there. Okay, these are the, as you see in Excel, you can also view the same thing here. There is slight difference between the Excel and the commands which use in Excel. The same commands also can be used here, like cut, copy, paste, everything. You can use the Control-C, Control-V options which you will be using. So these are the menus which will be available: file, edit, data, view, data, transform, where the transform section where you can compute some formulas which is required for your analysis, and you can recode data. And analysis is just going to perform statistical procedure. Graph will be able to create the graphs and help to access the SPSS information if you need access them. This is a window. While entering the data, you will be seeing wherein if you look at this, you can see like Excel file wherein the cells are appearing. And if you see the down, you have two views. One is data view and another one is the variable view. Right now we are in the data view. Wherein you can see the headings VAR. Those are the column headings which we can do. But here the column heading cannot be typed in directly. We need to go to the variable view for getting it done. See, these are the pull down menu bars, toolbars, information bar as in your Excel thing. Okay, and whenever there is an active cell, it will be highlighted, and whenever in which view you are, like data view is highlighted in yellow, similarly it will be an action bar that tells whether your analysis is ready or not. Okay. And then this is the variable view wherein I'm going to type all the column headings here. Okay, that is my motive. See, first the name which you are going to give it for the column, it should contain maximum of 64 characters, but initially in the SPSS it will be 8 characters only. Now it has been extended to 64 characters, and in between you should not leave any space while typing a name. For example, educational status, if you want to type in, you can write edu_status. Okay, you cannot put a dot or a space or a @ or # or any symbol cannot be allowed there. And type, you have to mention if it is a character, then it is a string variable. If it is a number, then it is a numeric variable. If it is a date, and then it is a date variable. Then with how much column width you needed for the particular thing, you can specify there. And decimals, if necessary, you can say 2 decimals or 3 decimals, whatever the thing which you have wanted to. And the label is, you have to describe the string variable which you are used. And values are nothing but the code which you are applying. You can elaborate the code in the values, and you can also say some of the values are missing in the data. See, this is the way. There are 2 options available in the analysis software. One is OK, another one is paste. What the OK does, OK is nothing but when I do analysis and I can run the analysis, okay, it gives the results for me. Then what is the paste option does? The paste option does just paste option. When you click the paste option, the syntax, that is the program which has been done by the SPSS, will be copied and it will be saved in the syntax file. Syntax is nothing but the program language which can be saved, and later I can run the programs and get the results done. Okay, see, that is the way. Here we can say there is 2 options. One is OK, another one is paste, where OK will be doing the analysis and giving the output immediately, where the paste options will save the program which you have created and it will be saved in the syntax file. And the syntax file, whenever you need the output, you can run the analysis. And this is the data, how you can enter the data, that I can also explain through the thing. And now the variable, see, these are the column headings which I'm going to have in my data, like ID, gender, program, reading, math. That is some of the examples which I add. That variable view will be active. Once you have completed this variable view, you can go to your data view. This is this data view. If you see initially we saw here VAR. Here in that VAR, we have initially we saw. Now it has in the data view. Now in the data view, you could see the ID, gender, grade, where we saw initially VAR. Okay. And whenever you wanted to read your Excel file, just open the SPSS data file, go to the file menu, click the read text data, and click files. You need not worry, I will show as a demo at the end of the PPT slides. And just this is just simply what are the things available in the menu. I am just focusing on that. This is data where you can sort your cases, or you can transpose a matrix, or all these can be seen in the data view. And analyze view, you will have a innumerable number of analysis for your data, and it will be listed like this. And I can just pull down that, and I can use it. Okay, and we have before going the next steps, I'm going to show a demo video wherein how you are going to use your SPSS. See, first initially you should need know two things. One is significant value, that is often in the statistics told as p-value. Suppose I'm keeping p-value 0.05 means, suppose I'm doing testing in 20 products. Out of 20 products, one may be having an error in the product. That is the significant value. So what I need to see in the significant value, if my p-value or significant value is less than 0.05, my error is very, very lesser than 5%. So I can say that the product is good. See, suppose you are manufacturing 20 products from a unit. All the 20 products, if you are taking, at least one will be the failure. Or suppose you are manufacturing 20 bulbs and one bulb by chance might be not glowing the way it usually glows. That is the significant value. Another thing you need to remember is confidence interval. Confidence interval is nothing but the interval which contains the true value, the interval in which the true it contains the true value. So if suppose I'm going to have a batch of 100 bulbs, definitely 95 times what I'm going to get a bulb definitely glows as perfect as my quality is being fixed. But 5 times I cannot get the quality which I have designed to get it. So it makes an error. Error is human. There is no person called 100% perfect. The person who has more perfect, like 75% or 85%, they are called as perfect. Okay. So similarly, when the manufacturer bulbs, so suppose 95 bulbs are perfectly up to the mark to the quality, then we can say the manufacturer manufactures the quality bulbs like that. So that is the confidence interval. So confidence interval in an interval where it contains the true value. So let's go for the demo. Today, in today's demo, the predictive analytics, most of the predictive analytics use regression. In the regression, it is linear regression, multiple linear regression, polynomial regression, and logistic regression. There are more and more kind of predictive analytics, but just I'm going to show some demo on these types of regressions. Okay, shall we proceed with the demo, or you need to ask some questions before I go to the demo? Any questions? So I take that after the demo. Yeah, after the demo, you could pose questions. So let us proceed with the demo. Okay. So first, I'm going to demonstrate on the linear regression. So first of all, I have a file named job performance. This is opening through IBM SPSS. Okay, this is my SPSS file where I have kept a few people whose performance and IQ level of each of the persons and the motivation that received from the employer and the social factors which they have. All these scores I have: performance score, IQ scores, motivation, and society. So all these are continuous variable. This is the data view which you are seeing in. As I said, these are the VAR. VAR is nothing but whenever you include a variable, then you can have, for example, suppose I go to the variable view. Already I have name, performance, IQ, motivation, and social factor SOC. So this is the name, performance, IQ, motivation. So suppose you want to include a variable, then you can have a provision here like ranking. What is the rank which we are given to a particular person? Just if you are going to include, automatically it takes these things. Whether your rank is a numeric or you are going to have a grade system like a category, that you can decide. See, normally ranking is a numeric variable, so I can have, suppose I have a date variable, then I have to specify it as a date variable. If you save in Excel as a date variable, here also it becomes as a date variable. And here in the label, what you can do, you can say ranking of the employee. Okay, like that, ranking of the person who is working, ranking of the worker. Like that, you can specify. Once you have done with this, and here for a continuous variable, you can see it's a scale variable. And for a name, it is a string variable. If it is a name, it is a string variable. String is nothing but the characters like alphabetical thing, all are named as string variable. And it will be nominal in nature because it's a naming variable, so it's a nominal measure, and all the others are continuous scale, so we will be having it as a scale variable. Other variables which you have is ordinal. Ordinal is nothing but a ranking variable, so rank should be a ordinal variable, so you can choose that as a ordinal variable. Sorry, rank is an ordinal variable. So all these stuff can be done before you see the data. This is the data understanding. What are the things you have in the data? Then we go to the data view. Since I have added a rank, now I have not given the rank for these people. So based on my IQ, I can rank the data. So where I can do the ranking is just go to data. Sorry, transform and just put rank cases. IQ outcome. Just for demonstration purpose, I have just given the rank as a variable, but it automatically generates the ranks. Okay, should I give smallest value a rank or largest value a rank? So I prefer largest value from 1. Okay, rank, and rank types, if you are just a rank, I don't want any scores and all, so I can have it as a rank. Okay, now this is the output view which you are seeing there. Now you can see the rank. This is the rank, it has been assigned. So I don't want a decimal, so I can go and correct in the rank the decimal places. Now what you can see is 3 decimals, you are having 2.00, but I don't want a decimal for the rank, so I can go and correct it here. Just it will go up, down arrow will make you to down. So 0, then see the data view. Now the rank is a whole number. So similar way we can create so many variables for the data. Now it is not necessary for our procedure. Now this is the data which we are going to use for linear regression. So linear regression, whenever I want to use a linear regression, first step is to see the correlation between these variables. What is correlation? Correlation is nothing but the relationship between all these variables. See, what is the relationship? As one increases, other increases or decreases. That is what I wanted to see that. So for the first step, just I go to analyze, and go to correlate, and here bivariate correlate. So what I'm going to do, analyze, correlate, bivariate correlation. Here I'm going to see whether the relationship between these variables exists or not. So bivariate. So once I click, all these things are coming. So outcome of a job performance, outcome of IQ test, outcome of a job, outcome of a social factor. So all these things I need to see the correlation. See, here this is the way you can pull down the variables and take it to the other side, and you can do that. Otherwise you can also at a stretch, but with the help of the shift down arrow, you can complete it and push the other side. Okay, so if you could see, there are three correlation coefficients. One is Pearson, another one is Spearman. Kendall tau is rarely used. Pearson and Spearman are often used. Pearson is for the continuous variable and Spearman is for the ranking variable. Now I'm going to see the Pearson correlation because all these are continuous variable, not category in nature. Once I click on OK, so I can see in my this is the correlation matrix. See whether my job performance test which I've kept is related to IQ test which I have already done. Okay, whether it is related. Yes, so there is a positive correlation. If you could see that 0.474 is a positively correlated. They have a relationship. As job performance test score increases, similarly IQ test is also increasing. Similarly, job performance test increases as your motivation test increases. Okay, job motivation test, if you get a score higher in job motivation test, similar there is a higher score in the job performance. And similarly, the social support. See, suppose if you are going to take a variable that is outcome of a social support versus outcome of a IQ, you can see a negative sign here. A negative sign here. That negative sign tells there is a negative relationship because social support test does not correlate with the IQ, that is negatively correlated with the IQ test, and this is the significant value which I have told. This 0.00 means it is lesser than 0.05, so there is a positive relationship and it is significant. But here there is a negative relationship and it is not significant. So I cannot consider for a larger score in the IQ, more number, maximum score in the IQ test doesn't correlate with the social support test, because IQ is different from, very much different from social support. Okay. Next, since I know that the outcome performance test is correlated with the IQ, motivation, and the, so I need to find out the graph. Okay, first I need to find out a graph. Just I'm going to have a graph between the performance test and the IQ test. For that, you need to go to graphs, legacy dialog. For all the relationship test, you need to have scatter diagram. Okay, regression, for regression to find out the relationship. See, to predict anything, we need to have a relationship. So scatter diagram, simple scatter. Correlation between the variables is very much needed. So in the x-axis, I'm going to put my job performance. I can put it in y-axis. It is not that you have to put in the thing. See, as your IQ increases, whether your job performance is also increasing, that I wanted to see. Just putting a graph in that. So this is, we call it as a linear pattern because as x increases, y is also increasing. You can also add a regression line, trend line towards that. This is the trend line. Now we will keep that aside and now we'll go for the analysis. See, for example, analyze. You have to go to regression, linear regression. Okay, for analyzing whether the job performance is dependent on IQ of the test. Okay, IQ. So for this, I'm using a simple linear regression. Simple linear regression. That is, I'm going to see job performance score increases as my IQ increases here. So what I need to do is, already I need to have a confidence interval, regression coefficients confidence interval, then continue. Okay. So this is the matrix which we got. நம்மள சின்ன வயசுல வந்து நம்ம படிச்சிருப்போம் இல்லையா, ஸ்லோப் கண்டுபிடிக்க ஒரு ஈக்குவேஷன் 10th ஸ்டாண்டர்ட்ல 10 மார்க்குக்கு வாங்கி இருப்பாங்க. y equal to mx plus c. We will give different values of x to get the value of y. அதே மாதிரி தான் இங்கேயும் இது அதே ஈக்குவேஷன் தான். நம்ம ஸ்டாட்டிஸ்டிக்கலா ப்ரெடிக்ஷன் வரும்போது y equal to a plus bx அப்படின்னு சொல்றோம். a-ன்றது கான்ஸ்டன்ட், b-ன்றது இன்டர்செப்ட், a-ன்றது இன்டர்செப்ட், b-ன்றது ஸ்லோப், தட் இஸ் m ன்னு நம்ம படிச்சிருக்கோம். அதுதான் இந்த இதுல ப்ரெடிக்ஷனுக்கு வருது. ஸோ இதெல்லாம் நம்ம எப்படி எழுதுறோம்னா, இங்க என்னது கான்ஸ்டன்ட் என்ன வந்திருக்கு, இந்த இடத்துல பாத்தீங்கன்னா கான்ஸ்டன்ட் இஸ் 49.782. அவுட்கம் ஆஃப் த ஐக்யூ டெஸ்ட் இதோட கோஎஃபிஷியன்ட் தான் அது 0.26. அப்ப இதை நான் ஈக்குவேஷனா நான் ஃப்ரேம் பண்ணணும்னா y equal to a plus bx. ஸோ இங்க பாத்தீங்கன்னா இந்த ஈக்குவேஷன் இங்க என்ன இருக்கு, y equal to 49.78. this is the a intercept plus 0.27. இதுதான் ஸ்லோப்போட வேல்யூ இன்டு எக்ஸ். நீங்க வேற வேற வேல்யூஸ் எக்ஸுக்கு கொடுக்க y என்ன ஆகுதுன்னு பார்க்கலாம். See, suppose IQ டெஸ்ட் இங்க சப்ளை பண்ணீங்கன்னா y யோட வேல்யூ ஜாப் பெர்ஃபார்ம் டெஸ்ட்ல அவர் எவ்வளவு மார்க் வாங்குவாங்க அப்படின்றத நம்மளால பார்க்க முடியும். இதுதான் லீனியர் ரெக்ரெஷன். இதே மல்டிபிள் லீனியர் ரெக்ரெஷன், எனக்கு ஒரு IQ டெஸ்ட் மட்டும் பார்க்க வேண்டாம், எனக்கு எல்லா வேரியபிளுமே நான் பார்க்கணும்னு நினைக்கிறேன் அப்படின்னா அது becomes a multiple regression. Again go to regression, linear regression, and I can include other things also like job motivation, outcome of social. Okay, now I can say okay. So என்னோட outcome of IQ test ஓட coefficient இவ்வளோ. இப்போ பாத்தீங்கன்னா இன்டர்செப்டோட வேல்யூ மாறிச்சு, ஏன்னா இதோட இன்ஃப்ளூயன்ஸ் ஜாப் மோட்டிவேஷன் அண்ட் சோஷியல் சப்போர்ட் வந்து கான்ஸ்டன்ட்டை வந்து நமக்கு வேற இடத்துக்கு கொண்டு போய் இன்டர்செப்ட் வந்து வேற இடத்துல மாறிடும். சரிங்களா? ஸோ அவுட்கம் ஆஃப் ஐக்யூ டெஸ்ட், அவுட்கம் ஆஃப் ஜாப் மோட்டிவேஷன், அவுட்கம் ஆஃப் சோஷியல். அப்ப இதை ஈக்குவேஷனா எப்படி நீங்க கொண்டு வரலாம் அப்படின்னா, y equal to, that is outcome of job performance is equal to 18.13 plus 0.265 into IQ plus 0.308 into job motivation plus 0.164 into it. இதை வச்சு நம்ம ப்ரெடிக்ட் பண்ணலாம் ஃபியூச்சரை. இவ்வளோ நாள் இவங்க வந்து இவ்வளோ ஐக்யூ மார்க் வாங்கினா ஃபியூச்சர்ல எவ்வளோ அவங்களோட ஜாப் பர்ஃபார்மன்ஸ் எப்படி இருக்கும், அவங்களோட ஐக்யூ லெவல் எப்படி இன்க்ரீஸ் ஆகும், அந்த மாதிரி நம்ம பார்த்துக்கலாம். This is all about linear and multiple linear regression. Now we will move on to the next thing is logistic regression. What is the difference between this regression and logistic regression is nothing but these outcomes. Like if you say the IQ test, it is a continuous value. Okay, it is a continuous value. Okay, this is the outcome variable. So I am going to test how the performance is based on IQ, motivation, and social factor. Then we can go for a regression, linear regression or a multiple linear regression. Now we are going to move on to the other regression that is called as logistic regression. Here I have a data for logistic regression. This is the data which I have for logistic regression. I am going to predict heart disease of a person is caused by a VO2. VO2 is nothing but aerobic exercise score. Okay, aerobic exercise score is VO2 maximum, and weight. Okay, weight and age as well as gender I have. So whether heart disease is based on the weight or the aerobic exercise which you are can be reduced using this, and whether male or female is going to get, and the age group. All these factors are the factors for getting a heart disease. We are going to see into that. This is the outcome variable I'm going to see. That is heart disease equal to what? That is the thing which I am going to see. Here heart disease is nothing but if heart disease is present in a person, we say it as yes, they have heart disease. If doesn't have, then it is a no. So now I'm going to see the logistic regression, that is analyze regression, because it's basically regression, and we are going to see the binary logistic. Okay, because the outcome is binary, no or yes. Okay, you can also go for a multinomial if you have more than 2 outcomes. So here I'm going to see whether logistic regression is basically whenever you have only 2 categories in the outcome variable, you can go for a logistic regression wherein you can link it with your engineering example. So here I have presence of heart disease, like yes or no, like that. You can link it with a dependent variable in a logistic regression. Always should have a 2, like yes or no, present, absent, working, not working, like that. You can have and see what are the conditions it can work, like that. Presence of a heart disease. Okay, and other variables I can take into as a covariate. Okay, and I can save some of the features. What is the I can go for an option. I can say this is called as Osmo-Lemichaud test. I need to check that, and I need to check my confidence interval, and I did not want constant in the model because just I wanted to know how my heart disease is going to predict. So now I'm going to say, okay. So when I did that, I said I need to have Osmo-Lemichaud test. What does this Osmo-Lemichaud test says is that here, this is the significant value. If it is lesser than 0.038, I cannot say that the model is really predicting the real world situation. The model which I have created is not predicting the reality of the world. Okay. Now the variables in the equations, these are the variables which are going to be predicting that. See, for heart disease, what are the things you need to have is, see, if you see the significant value, age. As your age increases, you might prone to have, because of the old age, you might prone to have a heart disease, and there are many factors, but that here I am not considered that. And weight is not here, and gender is one of the factor, as well as the VO2. But here I wanted to know exactly what are the predictors, what are the predicting variables. I have 4 variables: age, weight, gender, and VO2 max for predicting the heart disease. But I want at the last, what are the main variables which are predicting. So what I can do is that the same analysis which you have done is, you can click on this, whatever you have done earlier, it will be listed here. So I have did a logistic regression. So click on the logistic regression, and here the method, you don't put enter, you can have a backward in that. That is, it will run on its own and give which are the predicting variables more prone to have a heart disease. So here I'm going to click on OK. I am not going to go for the option because just now we did it, so it will be stored in that. So once I click on OK, now I'll see what happens to my osmolemishode test. Okay, this osmolemishode test, the first step which I did is not predicting the reality, but the second iterative step which I got, it really predicts the model very well. See, for example, what are the variables in the equation? You could see variables in the equation, and age, gender, and VO2 max are the more are the predictor variables which is predicting the heart disease of no or yes. So here you can see the exponential beta factor in the step 2, and this is called as this is the which we are going to explain. See, for example, the due to gender, there is a risk of 8 times getting a heart disease, and due to age, it is 1 time only. Okay, if you are male, you are more prone to have heart disease 8 times greater than the female. Why I'm saying male and female? Male I have coded as 1, and female as coded. You can also have a categorical description in here, and you can proceed with the analysis. So there are so many. So now for heart disease, the predictors are age, gender, VO2 with this example data. So if you have a real data, you can work on it with your engineering side. The basic application of logistic regression is that if your outcome variable is binary, like yes, no, present, absent, working, not working, like that, if it is there, then you can go for a logistic regression. Okay. So first we saw linear regression, then we saw logistic regression. The linear regression, the outcome should be a continuous variable, and in the logistic regression, it is a categorical variable with 2 categories like yes or no, present, absent, working, or not working. So next we are going to do a polynomial regression. Okay, next we are going to do a polynomial regression. What is polynomial regression? You might have learned a quadratic equation like y equal to a plus bx plus cx square, like that. If it goes, then we will have a polynomial regression. For example, for this data, since it is a COVID era, I have taken the COVID data, India COVID data from the website GitHub or John Hopkins website, CDC, Center for Disease Control. I have taken that. Why I have taken this data is here it is a Excel file wherein I am going to call that Excel file in the software. Okay, yesterday you might have learned Python or R. In Python or R, there are programs available wherein you can take the data straightly from the website and you can make it as an Excel file. That is how I have done this Excel file. And now we can go for the SPSS. Okay, because it is a Excel file which I have taken downloaded from the Center for Disease Control, John Hopkins University. They are daily recording the data of COVID. From that, for all over the world, from that I have taken the India data, how they have recorded. See, what I am going to do here is nothing but, see, in the month of July, we have so many cases of infected cases of COVID. What will happen in the August? So that is what I am predicting. Why I am choosing this polynomial regression? Because it is keep on increasing. Okay, it is not coming down. That is flattening of the curve. If you are aware of reading the COVID thing, everyone has intended to do the flattening of the curve. We are going to we can consider, see if it is this month is this scenario, what happens the next 15 days or next 30 days. If you wanted to predict more, there are so many models in your engineering. You can go and read that SARD model, that is suspectable, infected, recovered, death model, suspectable, infected, recovered, like that model, and suspected, infected model. All these are based on differential equations. If you're very strong in your calculus, you can go for that modeling, but that modeling is not possible in our SPSS, okay? But you can do it in R or Python, because solving a different, MATLAB also, solving a differential equation is not possible in the SPSS right now, but they are working on it. Now I'm going to take my Excel data sheet into the SPSS. So for that, as in Excel, just open as in your document or everything here. So I have kept this file in my desktop. So I'm going to that particular location, and I have kept that in the predictive analytics folder. Now you can see only the SPSS file. You cannot see the Excel file. So what I can do is files of type. You can choose here and go to Excel, because I have kept it as an Excel file. So I can take this as an Excel file. Now you could see the Excel file. Okay, then click on that and open. And click on OK. So this is what in the 1st of July, these many people are infected, and it keep on increasing day by day. So all the July data I have, I'm going to predict it for future. So for prediction, you can have the dates. What are the dates? You can say still yesterday, day before yesterday, I've taken the data. From that, I'm going to predict the next month data. Okay. So for this, what you can do is you should go to analyze. Just simply go to forecasting, just predicting. Okay, analyze, forecasting, and create models. Okay, define dates. All I have to define how my prediction should go on. Like every week, see, whenever a person is infected with COVID, you will be testing it. You will be getting the symptoms on the 5th day, and you will be given test result will be coming on the 7th day. This is the scenario which is happening over here. That's why the control measure takes a time. Okay. So here I am going to have weeks and day. Every week I'm going to split the data for the purpose of prediction. And you can have month days or work days, like 6 days are working. Then we can predict the data with the help of this. Okay. So I'm going to have weekdays. Then click on OK. So it has been created. Okay. Now I'm going to predict that. So what I'm going to have infected over here, and date over here, and then criteria. It is a date. Based on date, it will be created automatically. Took that criteria, and I can have some options. Sorry, I can save some of the things because I need the predicted values. I need to have a predicted values, as well as I need to have lower confidence interval as well as upper confidence interval. Okay. Then I can say OK. Once I have finished, it has some outcome. But the interesting part is, this is the red color which I have shown in the model is for the July, and for the August is still increasing only. This is the forecast. The blue color is the forecast. It's going to increase in the August, because some of the தளர்வுகள் அப்படின்னு சொல்றாங்களா, அதெல்லாம் பண்ணும்போது ஏதாவது இன்க்ரீஸ் ஆகிறதுக்கான சான்சஸ் இருக்குன்றதா இதோட prediction. Now you could go and see the predicted value. Okay, ஜூலைல இருந்தே இது predict பண்ண ஆரம்பிச்சிரும். So இப்போ நான் வந்து ஆகஸ்ட் 1st அன்னைக்கு, ஆகஸ்ட் 1st அன்னைக்கு நீங்க டேட்டா பாத்தீங்கன்னா it might be 17 lakhs. Okay, and this is the lower limit to upper limit. நான் predict பண்ண வேல்யூ இது ஆகஸ்ட் 1st அன்னைக்கு எவ்வளவு இன்ஃபெக்ஷன் கேசஸ் இருக்கும் ஆனா ப்ரெடிக்ஷன் தானே. ஸோ தப்பா போகலாம், ஒரு 5% தப்பா போறதுக்கான சான்ஸ் இருக்கும். அப்போ ஆகஸ்ட் 1 அன்னைக்கு இந்த வேல்யூல இருந்து இந்த வேல்யூக்குள்ள இன்ஃபெக்டட் கேஸ் இந்தியால இருக்கும் அப்படின்றதான் இதோட ப்ரெடிக்ஷன். ஓகேங்களா? இதுதான் ஆல் அபவுட் பாலினாமியல் ரெக்ரெஷன். சரிங்களா? இந்த பாலினாமியல் ரெக்ரெஷன் எதுக்கு யூஸ் பண்ணுவோம்னா, the cases keep on increasing now, how it is going to have that. ஆனா இந்த மாதிரி பாலினாமியல் ரெக்ரெஷன்ல ப்ரெடிக்ட் பண்றது வந்து சும்மா ஜஸ்ட் டு அவேர் வாட் ஹேப்பன்ஸ் டு டேக் சம் மெஷர்ஸ். பட் ஆக்சுவல் ப்ரெடிக்ஷன் நீங்க பண்ணணும் இந்த கோவிட் டேட்டாலன்னா மாடலிங் தான் பண்ணும். தட் இஸ் எஸ்ஐஆர் மாடல். ஆஸ் இன்ஜினியரிங் ஸ்டூடெண்ட் இட் இன்வால்வ்ஸ் டிஃபரன்ஷியல் ஈக்குவேஷன்ஸ். நீங்க தயவு செய்து போயிட்டு நிறைய பேப்பர்ஸ் போய் பாருங்க. அது வந்து எஸ்ஐஆர் அப்படின்னு ஒரு மாடல் இருக்கும், எஸ்ஐஆர்டின்னு ஒரு மாடல் இருக்கும், எஸ்ஐஆர் மாடல் இருக்கும். இது எல்லாமே இதுதான். எஸ்ன்றது சஸ்பெக்டபிள் கேஸ், அதாவது டோட்டல் பாப்புலேஷன் எவ்வளோ அப்படின்றத போடணும். இன்ஃபெக்டட் இந்த இதுல இருந்து எடுத்துக்கலாம். ரெக்கவர்ட் எத்தனை பேர், எவ்வளவு டெத் ஆயிருக்கு அப்படின்ற மாதிரி வச்சு ஒரு மாடல் பண்ணா. அப்படி இல்லை சஸ்பெக்டட் எவ்வளோ, எக்ஸ்போஸ் எவ்வளோ, இன்ஃபெக்டட் எவ்வளோ, டெத். இந்த பாலினாமியல் ரெக்ரெஷன்ல சும்மா சிம்பிளா இந்த 30 நாள் இப்படி இருந்ததுன்னா ட்ரெண்ட், அடுத்த 30 நாள் எப்படி இருக்கும் அப்படின்றது மட்டும்தான் இதால சொல்ல முடியும். பட் கரெக்ட் அக்யூரேட் ப்ரெடிக்ஷன் ஆஃப் ரெக்கவர்டு டெத் எல்லாமே வேணும்னா தென் யூ நீட் டு யூஸ் அ MATLAB or a Python. So this is all about my lecture. If you have any questions, you can ask me. This is a broader field. This is very much a broader field. If you want to learn more, where you can learn. You want to learn உப்மா எப்படி செய்வது அப்படின்னு கத்துக்கணும்னா என்ன பண்ணுவாங்க? ஃபர்ஸ்ட் இந்த லாக்டவுன்ல நிறைய அம்மாக்கள் வந்து எங்க போயிருப்பாங்க இல்லையா? யூடியூப். ஸோ உங்களுக்கு ரொம்ப இன்ட்ரெஸ்டிங்கா இந்த ப்ரெடிக்டிவ் சாஃப்ட்வேர்ஸ்லாம் உங்களுக்கு எதுக்காக இந்த இந்த இதில் சொல்லியிருக்காங்கன்னா, இவ்வளோ சாஃப்ட்வேர்ஸ் இருக்கு, இதெல்லாம் ஃப்ரீயா இருக்கு, இதெல்லாம் பெய்டு சாஃப்ட்வேர்ஸா இருக்கு. இதெல்லாம் ப்ரெடிக்டிவ் அனாலிட்டிக்ஸ். ஆஸ் அ இன்ஜினியர் இஃப் யூ சூஸ் அ கேரியர் இன் அ டேட்டா அனாலிஸ்ட், நீங்க நிறைய படிக்கலாம் அப்படின்ற ஒரு அவர்ஷனை கொண்டு வரதுக்கு தான் இந்த ஒர்க் ஷாப்னு நான் நினைக்கிறேன். ஸோ நீங்க எதை படிக்கலனாலும் யூ ஹாவ் ஆல் யூடியூப்ல போயிட்டு நீங்க ஒரு லெசனா படிக்கிறதுக்கான வாய்ப்புகளும் இருக்கு. அப்படி இல்லைன்னா டேட்டா கேம்ப், கோர்செரா இந்த மாதிரி நிறைய விஷயங்கள் இருக்கு உங்களுக்கு கத்துக்க. ஸோ ஏதாவது கொஸ்டின்ஸ் இருந்ததுன்னா சொல்லுங்க.
Thank you so much, ma'am, for your wonderful presentation and explanation on predictive analysis using SPS software. We are enlightened with your knowledge. In particular, your demonstration of SPS tool on predictive analysis is extraordinary. There is a question from Professor Jaivir Singh. How can classify the variable in SPSS? Ma'am, could you? Ma'am, are you there, ma'am? Hello? Hello?
Ma'am is not there, sir.
Okay, sir. Can we wait for her? I think her laptop battery is down. I think so. Ma'am, kindly unmute yourself.
Yes,
Yes, ma'am.
yes. நடுவில் கட் ஆயிடுச்சு நெட்வொர்க் ப்ராப்ளம்.
No issues, ma'am. Thank you so much, ma'am, for your wonderful presentation and explanation on predictive analysis using SPS software. We are enlightened with your knowledge. In particular, your demonstration on SPS tool is very useful and extraordinary. There is a question from Professor David Singh.
Yes, sir.
Yes, sir. How can classify the variable in SPSS?
Classify the variable means basically what we are collecting, those variables we will be having, and based on that we can classify. You want to make the categorization of variable or classification technique you want?
Okay, ma'am.
I couldn't get you.
There is one more question. How to publish paper on COVID?
Just there are so many papers available. Modeling is one of the important area where you can focus. The data are readily available for Tamil Nadu, India, and Chennai. By India data, you can easily with the program or with the Excel CSV file is available. From GitHub, you can take the CSV file. And for Chennai and Tamil Nadu, you have to go for the Stop Corona website and you can take the data. So you can do a modeling, predictive modeling, like control measures like that you can use, like age is a factor, or if you're going out daily for work, that is a factor that you can predict with the help of that. If you have the data like age, gender, and all those things, with that you can predict a model. Modeling is an important factor in coding. Yes.
Thank you so much, ma'am, for patiently answering all the questions raised by the participants. Now I invite